Today we'll be discussing authorization. So last time we covered authentication and different ways of doing authentication, including various mechanisms for two-factor authentication. So today we'll move on to the next step after authentication, which is authorization. So here, what is the role of authorization? What are we trying to do in authorization? Okay, very good. So in general, we abstract what users want to access. We abstract them, we call them resources. It's a generic name that refers to anything that our applications are managing. So, and then we have a user, and this user, this picture shows it quite nicely. We have a user, and this user are trying to access some resources here. And they try to do some actions on these resources. Maybe they want to view this resource, or maybe add or update. So they want to do some actions on a resource. So we check, there are many ways of doing it. One way is to check the role of the user. And based on the user role, either to allow the user to do the action they have requested, or we deny them that access and we give them an exception. You are not allowed to do it. So that's what authorization means. So authentication is a prerequisite of authorization. So before you can do authorization, of course, you have to know who the user is. You have to get some attribute of the user. And based on those attributes, you make a decision. So it's quite straightforward. So there are two major models that are used in practice to manage authorization. One model is called RBAC, role-based access control, and another one, which is now kind of more trendy approach of doing it, is attribute-based authorization, ABAC. So we have RBAC, which is a traditional way of doing it, and there is ABAC, which is a more flexible and more powerful way of managing authorization. So let's take a look closely at each of these models and discuss them together. Okay, so the first one is a role-based access control. So this is how this role-based access control really works. So what we have is we have roles. And these roles, from where do we get the roles?
Predefined roles?
Yeah, from where? Yeah, they are predefined, but from where do we get them? Sorry? No, that is... yeah, I understand. In terms of implementation, yes, it will be one of the attributes of the user. No, what I mean, when you are designing a system, when you are doing the requirements analysis and design, you need to identify the roles.
Depending on the type of data that we have?
No, the roles are not depending on the type of data. How do I identify the roles within an organization?
We have the admin, which has access to everything. We have the user.
No, before we talk about what they can do, we have to identify the roles within an organization. So what's one way of doing it?
Save in database?
No. This is what I mean, the analysis stage.
Job.
Okay, very good. Yeah, that's good. But from where in an organization, from where we get this information? You haven't seen something like organizational hierarchy? Yes, you have seen such thing?
Yes.
So we can start from here, from the organizational hierarchy. You have the CEO, you have directors, and then, like let's say in QU, you have a president, you have colleges, and there is a dean at each, managing each college, and within the colleges there are departments, and within departments there are faculty, staff, students. So you see here, so from the organizational structure, we try to find the roles. So roles are basically well-defined function within a particular organization, and they have certain goals and they have certain responsibilities. So first we have to identify the roles in an organization, and then whenever we build an application, we see what resources this application manages, And for each role, what are the permissions we need to give to these roles for them to do their work, or for them to achieve their role, basically. So fundamental thing we need to do first is to identify what are the roles, and then what permissions these roles need to do their day-to-day job. And then finally, we'll have users, and then when users come in, we assign them to roles. And because once we assign them to the roles, they have access to all the permissions associated with the role. And this is very important to make it easier to manage authorization. So you might, naive way to look at it, you might say, okay, I give permissions to users. If you do this, then this is not maintainable. And I gave you before the example, let's say, as a student, you have some permissions in QU systems. For example, you have a read access to Blackboard. You have permission to add course, to remove course, to drop a course. You have permissions to see transcripts, and so on. So ITS, when they set up an account, they don't need to go and assign permission to each student. It will be tedious. We have 20,000 students. We don't want to go and give permissions to each student. Instead, what we do, we create a role, student. And then we create a role, faculty. And then we create a role, admin. We create a role, let's say, CEO or senior administrator. And then we give permissions to these roles. And then when we have a new account, all we need to do, assign a role to those accounts. If we, let's say, at the beginning of the semester, we have 1,000 new students, we just create their accounts and assign them the role of student. And they will get all the permissions that's all other QU students are having. So it significantly reduces the management overload to manage permissions. So that's why it is a very popular model. In here, just some terminology you might come across when you are doing authorization. You will hear this term subject or principal. It's nothing but the user. And by the way, the user, it could be a person or it could be another system. Because remember, applications talk to each other. And a user or a subject or a principal, it could be a person, it could be an automated agent. The other thing you will come across when we talk about authorization is a resource or an object. This is the resource that the subject is trying to access, either to view or modify or delete or add. So those two terms, you need to keep them in mind. We have the subject, or also called principal. This refers to the user. And we have a resource or an object. This is what the resource, the subject is trying to act upon. An authorization is nothing but to decide who can do what. And also what nature of access the subjects can have on the resource. It could be read access, it could be write access, it could be delete access. So this is what authorization is all about. So traditionally, people used to use something known as mandatory access control or discretionary access control. The big names, all we say here is we have users or groups. In this model, MAC or DAC, we have users or groups, and we have permissions. Those users have permissions. This is still heavily used in operating systems. In operating systems, in the OS, you have users, you assign them to groups, and then you give permissions. So it is slightly different than RBAC. So this is the difference. Have a look at this. In this model, MAC or DAC, basically groups, we use the concept of groups, putting users together. So groups are a collection of users, while in RBAC, a role is a collection of permissions. it is also represents a job function within an organization. So a role in ABAC, it's really coming from the organizational structure. So we go to the organizational structure and say, what business functions we have? Maybe we have financial manager, we have accountant, we have a research officer, we have a transport manager. Those are roles. Those will become roles in your application. While in operating system, you might have you might have group of users, but not necessarily based on their role within the organization. It's just a group of users. For example, let's say CSE faculty. Those are group of users, not necessarily, or CSE. That's faculty. CSE, let's say members. It includes staff, staff, faculty, all of them put in one group. And we say these CSE staff and faculty, they will have access to this, let's say, to this directory in a server. So when you are giving permissions to users or group of users, that is not called role-based security. It's called discretionary access control, or DAC, discretionary access control. So in a role-based, we have, as I explained, like we have the concept of a role coming from the organizational structure, and once we define the roles, we assign permissions to the roles, and then we assign users to roles. That's basically the idea. So here is an example. So here I have some roles here, like manager, writer, and guest. And the resource we're trying to manage are blog posts. This is the resource we're trying to manage, blog posts. And these are the permissions. The roles can act upon these resources. So for example, the manager, they can read and write and publish. The writer, they can read and write. They cannot publish. It has to go through the manager to publish. And we have a guest, they can only read, they cannot write and publish. So here is how you define. You define the roles, you define the permissions of these roles on this resource, in this case, the blog posts. And then we have assigning users to roles. So we have users and we say, here are the roles of these users. So to summarize, here is the generic view how role-based access control looks like, as I explained. We have roles, we assign them permissions, and we have users, we assign them to roles. That's basically the basic idea of RBAC. Now, if we go a little bit more in depth, we will find that we can also, in RBAC, we can also have another important feature. We can define role hierarchies. Similar to inheritance, you have seen maybe in software engineering, you can define inheritance relationships between roles, yes, between roles. So for example, what this inheritance mean, this inheritance hierarchy you're seeing here, what does it mean?
He has everything, he has the attributes of the class above him.
Yes, very good. So basically manager, they have all the permissions of the writer plus extra permissions of their own. While the writer, they have all the permissions of the guest plus some extra permissions. So one way to define it, this is just an example, like programmatically, you might define something like this. Have a look at this. So I have a role here, manager. They can publish. This is an extra capability they can do, an extra permission they can do. Plus, they inherit all the permissions from a writer. And here I have a writer. They can do one extra operation or permission. And plus, they inherit all the permissions from guests. And then guests, they can read. So in some frameworks, role-based access framework, role-based authorization frameworks, they allow you to define your roles this way. So this way, it's significantly simplifies the permission management. So you define roles and you define inheritance hierarchy between them, and the like the lower level, like let's say here manager, they inherit all the permissions of the upper. Like the manager inherits all the permission of the writer, and the writer inherits all the permissions of guests. And of course, you can add extra permissions. Exactly the same concept of inheritance you have seen in programming or on software engineering, where we have a superclass and a subclass. So the subclass has all the properties and methods of the superclass, plus you can add extra behave. So similar concept here. So here is another example here. So in here, the more specialized, the more you go up, the more permissions you have. This is just an example. So here what I have here is, we can reverse it, I think maybe makes more sense. But anyway, so what we have here, this is in a hospital application. So we might have here a healthcare provider. And then this is the generic role. This is a generic role. Then we split the roles into nurse and physician. And then we have some permissions for the nurse, some permissions for the physician. And then we split the role even further to emergency room nurse and intensive care nurse. And these two roles, they even have more permissions than an ordinary nurse. Same thing for the physician. They might have some permissions. And then we have yet other split. We have primary care physician and specialist. They might have extra permissions beyond the ones associated with the physician. So this role hierarchy allows us to manage permissions and make it easier to manage permissions and manage authorization. Okay, so that's another feature you can do with the role-based access control. You can define role hierarchies. The other thing you can do with the role-based access control, you can define constraints. You can define constraints. For example, you can define mutually exclusive roles. For example, one person cannot do two roles at the same time. Why is it? Why is this is important in practice?
For example, some conflict of interest.
Thank you very much. Some conflict of interest. This is very important. It's called separation of duties. So, for example, we have somebody managing expenses should not be the same that the one who approve expenses, because we don't give the opportunity to have some conflict of interest. Somebody who managing the hiring should not be the one who approves the hiring. So we have to separate these roles. So this is called separation of duties. Yes, please.
That's what would be less cohesive.
What do you mean?
You can't focus on both at the same time.
No, it's not. It's not really the concern there. The concern there is just to avoid abuse, because if somebody, let's say, is managing expenses at the same time approving, then they might add their own expenses and approve them. So you really need to have that two level. So in an organization, you will always find this. You will have one that does the work, another one that approves it, and they should never be the same. Yeah. So hiring, same thing. They might hire somebody from family or somebody not really qualified for the job and approve it. So you really need to separate those. It's easy for them to approve, but it's not really to avoid to avoid for them doing multiple things. These things are anyway related. They are very much related, but we separate them to make sure we have separation of duties, to avoid conflict of interest and to avoid misuse. This is important. So in a role-based access control, you can define these constraints. Cardinality. You might go to a role and say, this role, we can only place one person or two. Let's say for a president, university president or company CEO, you can only have one person in that role. So you can have a constraint. Another one is a prerequisite role. So for example, if somebody wants to, let's say head of department is not available. There is a role called head of department. And then we want to assign somebody to take that role, even for a short period of time. We might define a prerequisite. So for somebody to assume the role of head of department, they must be coordinator, for example. So you might define a prerequisite for someone to take particular role. They must already have a prerequisite role. So these are example constraints you can define on role-based access control. So in practice, role-based access control, you will find some libraries out there that will help you manage, that will help you implement a role-based access control. So if you are using, let's say, Node.js, you will find a library for ABAC. If you are using .NET, you will find some library to help you do that. So for example, if I go here, ABAC, Node.js. There are libraries. You see here, for those of you familiar with Node, there are libraries that help you do this. When I say libraries, they will help you to do exactly this. It will help you to define the roles, help you to define role hierarchies, help you to assign permissions to roles, help you to assign users to roles, and help you to define constraints. So this is this. By the way, this is a standard way of managing authorization in realistic applications. In fact, this example was taken from one Node.js library. As you can see, it nicely allowed me to define the roles and define the hierarchies and define the permissions of each role. So you don't need to start from scratch. Here, of course, we don't have the chance to go into implementing this, but at least we are familiar with it conceptually, and you can use, depending on the language you are developing with, you might use an existing framework to help you set up and manage authorization using a role-based access control. Is the idea clear? I think it's quite straightforward. Now, as you might see here, a role-based access control, it's very powerful. It helps us reduce the maintenance and the effort needed to manage authorization. But it's not that flexible. So let me give you some scenarios. Let's say, as a student, you have the permission to register a section in Banner, as an example. But is this permission always available?
No.
Yeah, so what is the problem here? So if you want to register a section,
sometimes you didn't pay your tuition.
Very good. So for example, there are some conditions. For example, you look at the subject, which is the student, and say, is there any lock in their account? Some students, they might be in probation or they have some issues. There is a lock in their account, they cannot register. Or they haven't paid, maybe there is a lock in their account. The other thing, so basically it's not, we make a decision to allow or deny, or permit or deny, not only based on the role. This is a bit naive, just the role itself is not enough to make a decision whether to permit or deny. So in this scenario of even registering a section, we look at many things to make a decision. So for example, as we discussed, we look at whether there is a hold on the user account, on the student account, what else we should verify?
Whether it is conflict with another course.
Very good. It's conflicting with another course, or more importantly, you have to do it within the registration period. There is a registration period, so there is a time interval. So you look at a time. If it is within the time, the registration period, it allows you to do so. Otherwise, it will not allow you. It might also look at the capacity, the current capacity of the section. It will only allow you to register if the current enrollment is less than the current is less than capacity. Yeah. So what I mean here, usually we evaluate different attributes, either attributes belonging to to the user, such as there is a lock on, there is no lock on the student account. Some attributes belonging to the resource. For example, whether the section has capacity or it is full. Sometimes we look at attributes belonging to the environment. Environments such as the time. So for example, the registration is only allowed within certain time interval. So that's why role-based access control is not enough. So we have another more flexible and more powerful model. We call it what? It's not role-based, it will be? Sorry?
Hierarchy-based?
Hierarchy-based? No, the role-based, you can define hierarchies. We call it attribute-based. Attribute-based. What do we mean by attribute-based? So, for example, for giving the permission for the student to register a section, we looked at many attributes. We looked at attributes of students. You know what's an attribute?
Yes.
Yeah, same concept as in database or in object-oriented programming or modeling. It's a name-value pair. It's some kind of characteristic of some object and a value associated with it. So, in the case of registering a section, what were the attributes we looked at to make the decision? We looked at the time, very good. Those are environmental attributes. We call them environment attributes. Now let me go ahead. Such as the time. This is the environment attributes. We also looked at the students themselves, the user themselves. What attribute did we look at for the student? First, we look at the role because the user role should be student. Otherwise, you cannot register the section. What else? Very good. Whether there is a lock on the account, that's an attribute belonging to the user. We also looked at other attributes belonging to the resource they are trying to access. In this case, what resource they are trying to access when they want to register? The section. The section that they want to register in. What attribute did we check?
Probably the prerequisite or something.
Maybe prerequisite, maybe the capacity. Or both, in fact, both. The capacity. The capacity should be should be greater than the current enrollment. Otherwise, you cannot register. So what I mean, at the end of the day, have a look at this. At the end of the day, authorization is just a binary decision, permit or deny. In role-based access control, how do we make this decision whether to permit or deny?
Based on that.
No, in the role-based access control, or RBAC. Based on the role. It's not flexible enough. It's good enough, but it's not flexible, it's not powerful, it's not realistic. So a better way to do it is to do what? Attributes-based access control. Now, attributes-based access control, what are the three types of attributes we can evaluate our rules against to make a decision whether to permit or deny? They could be attributes belonging to the user. It could be attributes belonging to the resource, or could be attributes belonging to the environment in general. So an example attributes belonging to a user, it could be the role, it could be the age, it could be it could be the major, and so on. It could be the number of credit hours accumulated so far. Many attributes we can look at. Now the environment. What could be example attributes? Environment attribute. Time. What else?
Capacity.
No, capacity is an attribute belonging to the resource. It's a capacity of the section. It's not environment. It could be from where you are trying to access to get this permission. Are you doing it from QU network or are you doing it outside? This is an environment attribute. You know, sometimes some systems, they allow you to do it in the campus, not outside campus.
IEEE.
As an example, yes. So you see here, the environment also, that's an environment variable from where you are accessing, in campus, outside campus. Another example, environment variable.
The server itself is available.
Sorry, Dave?
The server itself is available.
But that's not to do with security. What I mean here, at the end of the day, we are making a decision on authorization, whether to permit the user to do what they asked for or to deny, permit or deny, yes? So to make that decision, we look at attributes from the user, attributes from the resource, attributes from the environment. Example attributes from the environment, we set the time, we said from where, is it from in campus, outside the campus. It could also be what device you are using to access it. You might be allowed to access it from computer, not from mobile, for example. It could be. So those are environment attributes. Another very important thing in attribute-based access control is this one. This is very important to understand. Here it is. So what we do is the decision either to permit or deny, you should not be coding it in your implementation. You should not put those decisions and these if statements and evaluating these rules. It should not be part of your application. In fact, you should do the authorization. The authorization should be managed in an authorization engine. So if somebody wants to do some action, what should we do?
We check the authorization.
We ask the engine.
Send all the information about the user, environment, resource, and the authorization engine will take the decision.
Very good. Thank you very much. Now, how does this authorization engine make decision?
Check for example, the role of the user, check the environment lifetime.
Very good. Sorry?
It will be like a program.
Pre-programmed, yes. Yes, it is a rule engine basically at the end of the day. We feed it the policies. You see here policies? Policies are rules. The rules that need to be satisfied for authorization or permission to be granted. So this way, remember, similar to what happened in database. Before databases, applications used to manage their own data. You may be reading or writing to files. But these days, nobody do that. Well, if you want to manage data, what should you do? You take it outside your application and you manage it in a database. You don't manage it within your application. So the database is the one that will be storing, retrieving, and taking care of the data. Same thing here. The permissions and managing authorization, we don't implement it in our application. Where should we implement this authorization? In an authorization engine. And what this engine really does, what's its role?
It checks to permit or not.
Yes. It will evaluate these policies. It will evaluate these policies and give us the go-ahead either to go ahead and allow, permit, or deny. So what I want to say here, for managing authorization, you take it out. You take it out of your application and you manage it separately in a separate engine called authorization engine. Now, we also have a standard way of doing it. There is a standard called XAML, Extendable Access Control Markup Language. Extendable Access Control Markup Language. What do we use this language for? You remember, to manage authorization, we need to create policies. So we create these policies not using if-else statement. There is a language to express those policies. So this language is called XAML, or Extensible Markup Language. Extensible Access Control Markup Language. So there is a Wikipedia page. There is, of course, this is how it looks like. This is Extendable Markup Language. It allows us to define attribute-based access control policies. When I say attribute-based access control policies, basically the rules that we need to be satisfied for the user to be granted access or deny access. Okay, so this XAML, what it does, it provides us two things. The first thing, it gives us a language to define access control policies. It also defines a standard architecture. If you want to build an authorization engine, there is a reference architecture. There is a well-known architecture you can follow to produce a good, to have a standard-based authorization engine.